we will write a Python program to create a linear regression model. The model will predict what the pecan production will be if a farmer provides information such as how much water per acre is applied, what the salinity level of the soil is, and the amount of fertilizer applied on per acre land. I have this CSV file that contains the data. The CSV file contains 4 columns. The last column is the dependent variable, which is pecan production, that is the harvest of pecan per unit land. The other 3 columns are independent variables: water per acre, salinity level, and fertilizer per acre. Again, the pecan production is the dependent variable, which is dependent on the independent variables: water per acre, salinity level, and fertilizer per acre. From the previous part of the linear regression, we know the formula to predict will be intercept plus coefficient with the water per acre times water per acre plus coefficient with the salinity level times salinity level plus coefficient with fertilizer per acre times fertilizer per acre. Creation of the model in the context of this data is figuring out the intercept and the 3 coefficients for the 3 independent variables. Let us start with our Python code. We will use pandas and matplotlib's pyplot. Import numpy2. We might or might not need it. I'm using Jupyter Notebook. I will use a little bit of visualization. I want the visualization plots to be inline and saved with the Jupyter Notebook. This is why I have written this line, matplotlib inline, this way. I'm creating a data frame object df by reading the CSV file pecan.csv using the pandas readCSV method. We already saw the pecan.csv file early in this video. To verify if the data frame has retrieved the correct file, I am looking at the head. The head function is showing me the first 5 rows and the header. It is looking correct to me. I am using the data frames info method to get some metadata about the table. This shows me the features or column names or the variable names. As discussed before, we are interested in a model that will help us predict the pecan production. Therefore, pecan production is our dependent variable in this context. Let us try to figure out its relationship with the rest of the columns through some initial investigation via visual inspection. In a 2-dimensional scatter plot, I am taking the water per acre column in x-axis and the pecan production column in y-axis. The plot shows that the more the water, the more the pecan production is. Changing the x-axis to salinity level, we find that the more the salinity level, the lesser the pecan production is. This indicates that pecan plants do not like salt in the soil. I should disclose that the data I am showing is not factual and is made up. Therefore, please do not take this data as a basis for agricultural scientific fact. Back to the topic. Let's see what happens with higher fertilizer per acre. We see that the pecan production tends to be higher with higher fertilizer per acre. That is, with more water and fertilizer, pecan production is higher. And with more salt in the soil, pecan production is lower. This is our initial observation based on the visualization. Let us see what a linear regression model says and how we can use the model for prediction. We will use scikit-learn's linear regression class for creating the model and do the prediction.